At cloud scale, traditional techniques of scripting and in-place system construction simply won't work due to the number of systems and the number and frequency of applications that need to be deployed. RPath's approach to application deployment and systems management is twofold. Number one, RPath believes in applying the best practices of software engineering and version control to system construction. RPath version controls all elements of the system stack, all the way from the operating system through the middleware and the applications and the configuration, tightly controlling exactly what software should be deployed at any point in time to any system. Number two, RPath believes in a declarative model for a system and application deployment. A declarative model explicitly defining the exact set of software and configuration that should be deployed for an application and system stack at any point in time. To achieve this, RPath Cloud Engine provides a version control repository. Into this version control repository, RPath imports applications, middleware, operating system, and the configuration elements that go along with each of these software components. As each of these software components and configuration elements are imported into the RPath Cloud Engine, RPath automatically applies a set of policy, an extensive set of policy around each of these elements. Most importantly, these policies include automatically inspecting each of these software components at the file level for dependency information and for capability information, ensuring that we can accurately represent dependencies and create a declarative model of an application deployment or system stack that is fully 100% dependency resolved, that is correct by design prior to actually deploying the application or deploying the system. We get it right in advance. From each of these software and configuration elements, RPath Cloud Engine builds a system model, a declarative model of what the application deployment and software stack should look like for a particular system at that point in time. For example, a particular application deployment might include a particular version of the application, the middleware, and the operating system. Each of these elements are explicitly defined and version controlled. The system model itself is also version controlled. This guarantees an explicit set of software and configuration element to be deployed. Again, 100% dependency resolved and correct by design prior to actually making the deployment or the system provisioning. What can we do from this system model? We can execute 4 high-level tasks. The first thing that we do is, of course, deploy brand new systems. RPath Cloud Engine provides an abstraction layer to build about a dozen different image types, all from the same system model, guaranteeing that the software installed on a system, regardless of where it's deployed, is consistent, identical, and the same. RPath can provision images for traditional physical deployments. For example, ISO images, installable ISOs, virtual deployments, supporting all of the popular commercial and open source hypervisors, such as VMware, XenServer, and others. And of course, private and public cloud technologies, including Amazon Web Services, Eucalyptus, OpenStack, and more. Again, each of these images are constructed by RPath at the push of a button in an automated fashion, all from the system model, guaranteeing consistent deployments of the application and the software underneath that application deployment, regardless of the target, right? Optimized, of course, for the target, but a consistent set of application, software, and configuration for each of these targets. Because the system model is a canonical reference for exactly what software should be deployed at any point in time, because the system model is the unit of management, we not only deploy new systems using the system model, but we drive all change through this declarative model. So as new applications or revisions of the application stack come in and are imported into RPath, again, we run policy, we inspect this new version of the application for new dependency information, perhaps it's pulling in new libraries from the operating system. We'll remove any dependencies that are no longer required, perhaps functionality been deprecated by the new version of the application. We'll update that version of the application in the system model, and we'll revise the system model itself, again going through 100% dependency resolution to make sure that this new version of the system model is 100% correct by design and capable of being deployed to existing systems. Once we update the system model, then RPath Cloud Engine can go out and update all of the system deployments from the previous version of the model. We incrementally update deployed systems by calculating exactly what the difference is between the state, the exact current state of the system, and its new system model. We calculate that delta and deploy an update change set to those deployed systems. Even if the system itself has drifted over time from its original system model, we will figure that out. We will calculate down to the file level what changes have occurred, and if necessary, deliver a unique incremental update change set to each of those deployed systems to bring them in line with the new revision of the system model. And that's the second task that we can accomplish. The third task that we accomplish is audit for compliance purposes. And so since we know exactly what the state of the system is currently and what it was built from the system model, we can easily determine how the system has drifted over time. So from an audit perspective, down to the file level, we can determine what's been changed. Perhaps an operator has logged into the system and installed software out of band. More commonly, perhaps they've made configuration changes. We will detect those changes down to the file level, be able to compare those changes to the system model from which the system was originally built from, and report on the differences, right? Enabling the user to audit their systems and report on what has been changed for compliance purposes. Not only that, but of course then we can remediate those systems at the user's discretion to the system model, bringing them back in line with the system model. Alternatively, the user can incorporate those changes that have occurred back into the repository, build a new revision of the system model that incorporates those changes, and capture those necessary changes into the system model. RPath has the capability to promote the entire system model through the stages of release. So all of this work that is done by importing applications, middleware, operating systems, and configuration is done within the context of a stage of release. This version control repository is actually broken out for each application into stages of release, such that we're actually providing a version control repository specific to, for example, development, QA, and release or production. All of the work of importing these application components, the software elements and configuration elements, is done generally within the context of development. Developers import these applications and software components. They iterate over system models, rebuilding those system models until they have it exactly correct in the way that they want to deploy the application. And then the entire declarative system model is promoted between each stage. This guarantees that because not only are we promoting the application of interest, but the entire software stack, this guarantees that the software stack that we've deployed into production for that application is the same and identical and consistent with the software stack that we utilized in QA, that we tested against, and that we developed against. Reducing the capability for drift between any of these stages and providing for consistent, repeatable deployments through the lifecycle of the application. So through the concepts of version control and a declarative model, RPath Cloud Engine provides consistent, repeatable application deployments regardless of where those application deployments may occur.